Okay, now let's look and see what all of this means when it says to approximate the measure of angle A to the nearest tenth of a degree. So I need you to look that in order to find the angles themselves, we are taking the inverse of the ratio of each particular trigonomic ratio. So tangent would be opposite over the adjacent leg, sine would be opposite over the hypotenuse, and cosine would be adjacent over the hypotenuse. So before we actually start looking at how to do it within a triangle, let's just look at the math behind how you would solve for an angle. So in number 1, I have sine A equals 3/5. Sine A equals 3/5. Now, our job is to solve for this angle A. So we would actually say the measure of angle A is equal to the inverse sine. That's how we got rid of the sine to get this A by itself. And you really don't have to write the measure of angle A of 3/5. Okay? Now, 3/5 is just 0.6. It's the trigonomic ratio. And then we just encounter the calculator. Okay? So if we go to our calculator, remember that our calculator needs to be in degree mode. Now, above sine and cosine and tangent, you see here it says the inverse of sine, the inverse of cosine, and the inverse of tangent. So you would hit second, inverse sine, and it pops up and it looks just like that. 3/5, or you could even type in 0.6 if you wanted to, and it gives you this measure. And what this measure is it's actually the angle. So we are going to say 36.9 degrees. Now, just showing you what this means mathematically, this is basically what we did. We did the inverse of sine to get rid of it, and we had to do it over here. But technically, all we really have to write is just this, the inverse of sine, and then we get our answer. So the calculator does all of the work for us. So now let's look at the cosine A equals 0.59. Now again, we are solving for this angle A. To get rid of cosine, we do inverse cosine, and we have to do it to this side here. So A equals cosine -1, and then the 0.59. So we turn to our calculator again. This time we do inverse cosine, and it's 0.59. Round to the nearest tenth, so we are going to say A is approximately 53.8 degrees. Now looking at the tangent one, we have tangent A equals 0.245. So we just typically just do this. Tangent -1 of this, that is going to equal A. So the measure of angle A is going to be approximately, we will turn again to our calculator. So the inverse of tangent of that ratio is approximately 13.8 degrees. Now, those three problems show you how to do the finding the measure of angle A mathematically. Now, remember the title of our notes was Solving Right Triangles. So our job is now to use the knowledge that we now understand about angles and to apply that to solve a right triangle. So we're going to baby step our way into this. We're going to look at number 4 next. It says find the measure of angle A to the nearest tenth of degree. Now it's very important to notice that we are dealing with a right triangle, and we do have C and A, and we have no idea the degrees of those, but we do have two sides of the triangle. So since we have two sides, we can proceed. Now, angle A is here, and I have to decide which trigonomic ratio to use. So I use the numbers that I have available to me. In regard to reference angle A, the 11 is the adjacent leg. The 16, of course, is the hypotenuse. So which trigonomic ratios deals with the adjacent over the hypotenuse? Well, the answer is cosine. So cosine angle A equals adjacent, which is 11, over the hypotenuse, which is 16. Now, that's going to tell us angle A. So we now say A equals cosine, which is the inverse, of the trigonomic ratio 11/16. So from here, we go inverse cosine 11/16, and the measure of angle A now is going to be 46.6 degrees. And typically we round angles to the nearest tenth unless we're told otherwise, and then sometimes we round them to the nearest whole. So we used cosine because that's what we had, okay? Now, question 5. Find the measure of the smallest angle. Now this is when you have to use your knowledge of triangles. Remember, the smallest angle is going to be opposite of the smallest side. So we're actually looking for angle B. Now, in this case, we have all three sides of the triangle. So we can actually use any trigonomic ratio that we want to. We can use tangent, cosine, or sine simply because we have all three sides. But for me, I'm just going to go ahead and use sine. So sine B equals, since I'm using B and sine, I'm going to do opposite, which is 28, over the hypotenuse, which is 53. And then I'm going to say B equals inverse sine of 28 over 53. I'm going to use the calculator to calculate that. So inverse sine of 28 divided by 53, and we get 31.9 degrees. So the measure of angle B is 31.9 degrees. And again, you have options on question 5 because you were given all three sides of the triangle. Now, please keep in mind in questions 4 and 5, we were asked to find the angle, okay? We were asked to find the angle. When we find angles, we are going to use an inverse trigonomic function. Now, moving to question 6, it says find the value of x. So the first thing you should notice is, okay, I am not finding an angle. They gave me an angle. So I can find this other angle very easy, but that's not what it's asking me to do. So I want you to note, okay, this is no inverse problem, okay, because we are not finding an angle. Because we are not finding an angle. The only time you're going to use the inverse function is when you are finding an angle. So this, we go back to our what we know to do with normal trigonomic ratios. You are given 38, you are given an opposite, and you are given an adjacent. So what trigonomic ratio deals with opposites and adjacent legs? That would be the tangent. So tangent 38 equals opposite over adjacent. Notice we're not dealing with angles here. We're not finding this angle, so we just cross multiply like normal. X is going to equal 28 tangent 38, and again it turns into a calculator problem. So 28 tangent 38 is now going to tell me how long that leg is. So that is 21.9 units. Okay, so this is now, it's actually meters because that's what's listed in the problem. Now, using the knowledge that you now have, you can now actually solve a right triangle. Now notice the box gets bigger because there's a lot more work to do, but it says solve the right triangle formed by the water slides shown in the figure. Round decimal answers to the nearest tenth, okay? Now the first thing that I need you to know is, what does it mean when it tells you to solve the right triangle? Well, the first thing that it's going to ask you to do is that it's going to ask you to solve for every angle. So the measure of x the measure of y, and the measure of z. Okay? Now, lucky for us, in the picture, everything is listed there. The measure of x is 42 degrees. The measure of y is 90 degrees. And we can easily find x, or z, excuse me, by just subtracting these two angles from 180. So this is 48 degrees. Now the next thing, we have all three angles. We now have to find all three sides. Now, again, we can see that there because we have xy. We're going to have xz, which is given at 50 feet. And then we're going to have yz, which we don't know. But we do know they're going to be in feet. Now, you have many options to do this. The first thing you could do is you could just pick one of them. So let's go ahead and pick this. I'm going to call this Z, okay? And sometimes it is easier to call it the lowercase letter instead of this right here. So let's just go ahead and call it lowercase z, okay? Now, for Z, its relationship to 42 or its relationship to 48. You have so many options now. Since 42 is in the diagram, I'm going to stick with 42, and I'm going to notice that Z is the adjacent leg, and 50 is the hypotenuse. So that's going to kind of tell me to do cosine 42, and that's going to be Z over 50. So Z is going to be 50 cosine 42. If I use my calculator to calculate that, 50 cosine 42, that is going to give me 37.2. 37.2 feet. Now, the next thing I need to find is this lowercase x. And if I still use 42, I can say sine 42 because x is now opposite and the hypotenuse is still the hypotenuse. So to solve for x, I would say 50 sine 42, and 50 sine 42 is going to give me x is approximately 33.5. So that is going to be 33.5 feet. Now, notice in this problem, we did not use an inverse trigonomic ratio because we had all three angles. Now, I did use sine and cosine just because I used 42, but I have the option of using 48. Now, one thing that I do want to caution is when you have this and we rounded that answer right there, I could have switched and done the Pythagorean theorem. But what happens is if I round that, so I'm going to actually show you this. So 50 squared minus 37.2 squared, and then I square root that answer, I get 33.4. Notice the answer was 33.5. So what happened is we experienced a little bit of round-off error. So I like to stick with trigonomic ratios because they avoid round-off error. So that is it for this lesson. The big thing that I want you to know from this lesson is right here. Trigonomic ratios, when you do inverse, you will find angles. That's the biggest part. To solve a right triangle, that means that you are going to find all three sides and all three angles.